Determine the distance between the numbers on a number line. We can graph the points if that's helpful. So you can go back to -2, and 3/4 is going to be almost to -3. And then 4 and 1/4, that's 4 to the right and then a little bit past 4. So we can think about how many whole spots are between there. So we have 1, 2, 3, 4, 5, 6 whole spots. And then there's 3/4 here and a 4th here. If we combine those, that gives us another whole. 4/4 is the same as one whole. So we have 1, 2, 3, 4, 5, 6. And then this whole makes 7. We can also graph 3.5. That is in between 3 and 4. And 5.5 is in between 5 and 6. So there's one whole here, half here, and half here. 2 halves make another whole, so that is 2. 1 whole, 2 holes. The red line shows a walking route from the restaurant to Millennium Park. What do you notice about the map? What do you wonder about the map? I notice that the lines that represent the streets start to look like a grid. Based on this route, I'm wondering if there is a faster way to get from the park to the restaurant. Or is there a route with fewer turns? Record the coordinates of the endpoints of a line segment as ordered pair. Record the length of the line segment. Move the line segment to the other 3 quadrants and complete the table. So I have the ordered pair is 3, 4. The second ordered pair is 8, 4. And the length, if we were to count, is 1, 2, 3, 4, 5. Now we can drag it into quadrant 2. Here I have -8, 3, -3, 3, and oops. And the length is still 1, 2, 3, 4, 5. Drag it down to quadrant 3. This first ordered pair is -7, -9. The second one is -2, -9. And the distance is still 1, 2, 3, 4, 5. And lastly, quadrant 4. There's 2, -5, 7, -5, and the distance is still 5. Record the coordinates of the endpoints of the line segment as ordered pair. Record the lengths of the line segment. Well, the length is 3. 1, 2, 3. The ordered pair are 4, 5, and 4, 2. In quadrant 2, -8, 7, and -8, 4. But that distance is still 3. This one is -3, -2, -3, and -5. The distance or the length of that segment is still 1, 2, 3. And in quadrant 4, find the lengths of different horizontal and vertical line segments that each have endpoints in the same quadrant. How do the coordinates of the endpoints help you find the lengths of the line segment? So here I have a vertical line, and it's in the same quadrant. I see the 4s match up, so that wasn't really helpful, but 9 and 4, let's see, if I take 9 and I subtract 4, that gives me 5. 1, 2, 3, 4, 5. Let's move it to a different quadrant and make it longer. Here I have 7, 9, or negative 7, 9, and negative 7, 2. The negative 7s match, but 9 minus 2 is 7. 1, 2, 3, 4, 5, 6, 7. It has a length of 7. If I make it shorter, 9 minus 6 is 3. That's 1, 2, 3. Okay, what about horizontal? This way, okay, 6 and 3. These 3's match up, so those aren't helpful. But this 3 and this 6 give me some information. I could also look at the 7 and the 4. 7 minus 4 is 3. 1, 2, 3. That distance is 3. You might notice that in a horizontal line segment, the y-coordinates match. But in a vertical line segment, it's the x-coordinates that match. We can look at the parts that don't match. And subtract to find the length of the line segment. Here's the equation for the length of the line segment. It says the absolute value of 7 minus the absolute value of 2 is 5. Choose one example. Explain how you use absolute value and the coordinates of the endpoints to find the length of the line segment. Well, let's look at a horizontal example. We look at the piece that doesn't match. So 6 is match, so we're going to use the 8 and the 3. And if you click this button, it allows you to pull up the toolbar so you can use the absolute value bars and say the absolute value of 8 minus the absolute value of 3, the part that doesn't match, equals 5. And you can see that the line segment is 1, 2, 3, 4, 5 long. Point A and point B are in the same quadrant and are endpoints of the horizontal line segment. The x-coordinate of point A is A, and the x-coordinate of point B is B. You can see here. We can find the distance from point A to point B by calculating the difference between the absolute value of A and B. So they subtracted their absolute values, like so. Point C and D are in the same quadrant, and the endpoints are vertical, or the endpoints are of a vertical line segment. The x-coordinate for C, I should say the y-coordinate for C is C, and the y-coordinate for point D is D. We can find the distance from point C to point D by calculating the difference between the absolute values of C and D. So we're going to take the absolute value of C and the absolute value of D and subtract those, like you see here. 2 points are 8 units apart. Which of these could be ordered pairs of these points? So these, they have the 0 that matches. 12 minus 3 would give us 9, but not 8. So we'll cross that one off. The 5s here match, and the absolute value of 10 minus the absolute value of 2 would give us 8, so that one could work. Here I have the negative 3's match, so we can cross those pieces out. And the absolute value of negative 9 is 9. The absolute value of negative 1 is 1. 9 minus 1 would give us 8, so that one could also work. Here I see the 6's match, so we're worried about the 15 and the negative 7. The absolute value of negative 15 is 15. and the absolute value of -7 is 7. So 15 minus 7 is 8. So it could be this one as well. Here the 2's match. So we want to look at the 10 and the 0. Well, the absolute value of 10 minus the absolute value of 0 would give us 10. So the 3 center ones are possible answers. That would give us a line segment that is 8 units apart. Two points are 25 units apart. Which of these could be ordered pair of the points? So I'm going to cross out all the things that match in both sets of points. So just to help us look at what is left to examine. Okay, so 35 minus 10 would give us 25. This one, the absolute value would be 47, and this one would be 33. If I subtract those, that gives me 14. So it's not this one. This one I have an absolute value of 30, and this one has an absolute value of 5. So if we subtract those, that gives us 25. Here I have an absolute value of 50 and an absolute value of 15. Well, that would be a difference of 35. So it can't be that one. This one I have an absolute value of 33.25 and 8.25. If we subtract this would give us 0 here. And 33 minus 8 is 25, so it could be that one. So we'll clear out this to select our 3 choices and submit. Record the coordinates of the endpoints of the line segments as ordered pairs. Record the lengths of the line segment. Move the line segment so that it extends into 2 quadrants. Complete the table. We want in quadrant 1 and in quadrant 2. So that's going to have to go this way, a horizontal line, in quadrant 1 and quadrant 2. -6, +7, +3, +7. That has a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we need quadrant 3 and 4. So down here, that is -4, -8, 5, -8, and that has a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9 also. To get into quadrant 2 and 3, that's going to need to be a vertical line segment. I have -8, 3, and -8, -6. Whoop, it has a length of 9. This one has endpoints 9 and 5. And this one has endpoints 9 and -4. That's supposed to be a comma. And it has a side length or a distance of 9. Here's the equation for the length of this line segment. Why do you use absolute value to find the length of a line segment? Give an example. Okay, so here's the one that matches the points I have here. You can see it has the absolute value, but this time it has addition in the middle. And so I have a 2 and a 3. It says, why do you use absolute value? Give an example. Well, if we used 2 plus -3, that would actually give us -1. If we started at 2 and went back 3, that would put us at -1. But we're looking for the distance. And distance is always used with a positive number. So we use absolute value to create positive values. We want the distance to say 5, not -1, so we need to use absolute value of both. Point A and point B are in different quadrants and are endpoints of a horizontal line segment. The x-coordinate of A says A, and the x-coordinate of B says B. We can find the distance by calculating the sum, that's an addition problem, of the absolute value of A and B. So you see they added them. When they're in different quadrants, we add the absolute values. When they were in the same quadrant, we subtracted their absolute values. 2 points are 33 units apart. Which of these could be ordered pair of these points? Now they're in different quadrants, so we need to add their absolute values. We're going to go through and cross off the things that are the same about them, because that just tells us whether it's vertical or horizontal. So now we're adding their absolute values. The absolute value of this is 30. The absolute value of that is 3. 30 plus 3 is 33. Absolute value here is 8 and 41, but 8 plus 41 is 49, not 33. 9 and positive 24, that makes 33. Here I have absolute value would be 33.25. Absolute value would be 10.5, which would give us 43.75. So that's too big. We want to get 33. And then we have 8 and 25. 8 plus 25 is 33. So we'll check the first, third, and fifth box. First, third, and fifth box. Use what you have learned about the distance between 2 points to help you move from point to point through the maze. To start, move to either of the points shown. Okay, so if we're starting here and we want to go down to this blue circle, we need to change our direction to say down. And if we are at 9 and 3, if they're in the same quadrant, 9 and 3 are in the same part, 9 minus the absolute value of 3 would give us 6. So we need to adjust this. We don't want to go down 6 or down 9. We want to go down 6. And so then we'll click move. Now we are here. And now we're going to move to the right. The 3's match. So we're looking at -1 and 9. A -1 and a 9 are in 2 different quadrants, so we need to add their absolute values. This would come out to 1, and 1 plus 9 would give us 10. So we're moving right 10. Now we're looking at going down again. The 9's match. The 3 and the -3 are in different quadrants, so we add their absolute values. That would be 3 plus 3, which is 6. Now we need to go left. 9 and 7 are in the same quadrant, so we subtract. The absolute value of 9 minus the absolute value of 7 is 2. Here we would need to go down. The 7's match. -3 and -5 are in the same quadrant. So we subtract their absolute values. This would be 5 minus 3, which is down 2. Continue moving along the map until you end up at the finish point. Find the distances between these two. First, we're going to cross off the things that are the same, and we're looking for whether these are in the same quadrant, which you can see they are not. If they are not in the same quadrant, we add their absolute values together. So this would be 456 plus 32,416. When we add those together, 456 plus 32,416 comes out to 32,872. Make sure that your workbook is filled in with any notes that you need to take from this digital lesson, and that your warm-up is completed.